Here with me, Zach. We are the executive tutors at the Fulton Steering Center. So today we'll be going over the CSE 100 final exam review. So for anyone who is new to the tutoring center or was not familiar where the tutoring center is, it's located in ECG 104. So it's that small room like once you get in the Palm Walk. So this is the agenda for today's review session. So these are the topics we'll be going over. Uh, Zach, did you start recording?
Oh, yes, this will be recorded.
Okay, yeah. Um, okay, so let's start by reviewing what an array actually is. So an array is it's a fixed size collection of elements, all of the same type, stored in a contiguous memory. The most important thing to remember is that arrays cannot grow or shrink. Their size is determined at the moment you declare them. Now, arrays use a zero-based indexing, meaning that the first element is at index 0 and the second element is at index 1 and so on. Now, in most problems involving arrays, we process them using loops. A loop allows us to access each position one by one and apply whatever logic we need, such as assigning the values or finding a sum or searching for minimum or maximum. So your exam questions in this unit frequently involve these ideas like accessing elements using indices and using loops to modify or read values and like how to compute totals or averages from array contents. So and let's look at two of these examples here. These are taken from your handouts. So in the first example, let's say we have some array of size 5 and we want to assign a random number to each element. So this is how you would do it. So here we loop from index 0 to 4 and assign each position a random number between -10 and 10. So here, like as the loop keeps iterating, each of the element in the array will be populated with a random number. And let's look at the second example here. So we have an array of size 5 from earlier, and let's say you want to calculate the sum and average of all the elements that are in the array. This is how you would go about it. So here we start by initializing a variable sum equals 0, and then we loop through the array, and at each iteration, we add the element to the variable sum. So at the end, we compute the average by dividing the total by the number of elements. At any point, if anyone has any doubts regarding the examples or anything, feel free to stop me. Uh, yeah. And Zach can move to the next slide. Yeah. So this section focuses on three essential array operations: swap, remove, and insert. So since arrays have a fixed size, none of these operations actually change the array's length. Instead, they work by manipulating or shifting elements. Swap simply exchanges two values using a temporary variable. Remove deletes an element logically, not by shrinking the array, but just by shifting all elements after the removed position to the left. Insert is the opposite. We shift each element to the right to make room for the new value. So these operations are important because they test whether you understand how array indices move when elements shift. So let's look at the first example here. The expression swap, the swap method, it swaps the values at index 1 and 3. Inside the function, we store one value in a temporary variable and replace it with the second value and then place the original value back. So that's how the swap method works. And then let's look at the second example. So here we're using the remove method. So we remove the element at index 2 using this method. So when you remove an element from a fixed size array, everything after it shifts to the left. So the last part becomes leftover data. It's usually like a duplicate because the array cannot shrink. We just reduce the logical size so that the leftover value doesn't matter. Yeah, next slide, please. The next section is about two-dimensional arrays. So a 2D array is basically like a table made up of rows and columns. Now, instead of using a single index like in one-dimensional arrays, we use two, a row index and a column index. So the syntax, it's like the array name and like two brackets. The first one is gonna refer to the row index, and the second bracket would refer to the column index. So yeah, 2D arrays are used in problems involving grids, matrices, seating charts, and so on. So exam questions often they require you to assign values to specific cells or loop through the rows and columns and like understand how nested loops map to a 2D structure. So let's look at the first example. So here we have a 2D array called my counts, and then we are trying to assign a value 3 to row index 1 and column index 2. So here the first bracket refers to the first row, and then the column, first row in sense like since the indexes start from 0, it's like this, like the second row technically. And then the second bracket, we're referring to column index 2. And we're just assigning value 3 to that place. Now let's look at the second example. So in this nested loop, we assign aij equals count, and b ji equals count. So uses the reversed indices. So its structure becomes a transpose of a. So A fills normally like from left to right and top to bottom, and B does this in the opposite way. So it fills from top to bottom and left to right. So it's like a transpose of each other. The indices are flipped. Yeah. Next slide. So vectors are similar to arrays, but with one advantage. They can grow and shrink dynamically. So instead of worrying about shifting elements manually, vectors handle all that work internally. So some essential functions include pushback to add an element, insert to add an element at a specific position, erase to remove an element, and pop back to remove the last element. So vectors combine like the advantages of arrays, but with easier memory management. So let's look at the first example. In this example, we start by adding three names using pushback. So each pushback takes the new value and places it at the end of the vector. So here, after these three operations, the vector will look something like an array containing three names like John, Mary, Chris. So it'll just add each of those names to the end of the array. And then we insert a new name, Yoshi, at the second position. We're doing this using the insert method, and then the name Yoshi would be placed at the index that is specified over there. And then names.begin, it returns an iterator pointing to the first element, which is John here, and adding one moves it to the second element's position right before Mary. So inserting at like begin plus one, it would place Yoshi between John and Mary. Uh, yeah, and now let's look at the second example here. So here we demonstrate two additional operations, removing an element and replacing an element. So to remove the third element, we use the erase method. Here again, begin plus 2 points to the element at index 2. So this erase call, it removes Mary, and the vector automatically shifts Chris to the left to fill the gap. And now the vector would become John, Yoshi, and Chris. And after that, we replace the second element with a new name. This directly updates the element at index 1, and the final vector would look like John, Yoshihiro, and Chris. And yeah, that's it for my part. And now my friend Zach will take over.
All right, so the next topic that we'll be going over is sorting algorithms. And I'm just curious, how many of you fully completed like handouts 17 and 18? Are those graded or are those optional? Okay. Yeah, so I'll be going over mostly the examples from the handouts. If you guys have um, how it says optional, but most of us follow on class. Yeah, I'll be going over some of the um, examples from those handouts, and the professor emphasized that these are the type of questions that will be on the final. So if you have any additional questions or additional concepts relating to these topics that you want to go over, we'll have the time after that. And then Vincent says, will big O notation be present on the final? Um, the professor told us to go over the topics related to handouts 11 through 18, and I didn't see any big O notation, so that would, unless it was announced by the professor, I'm not completely sure. So I would double check with the TA or professor himself. But yeah, we didn't see that in the handouts. So yeah, no problem. And then for the sorting algorithms, so the two that we went over in the handouts is bubble sort and selection sort. And for bubble sort, the first two elements are compared and swapped if they are out of order. And then you move on to the next two elements, and then this repeats for the rest of the algorithm. And then for selection sort, the smallest value in the list is selected and swapped with the current index. So we'll see an example of this on the next page. So for bubble sort, this is one of the examples that you had in um, handouts. I believe it was 16 or 17. But so we have this array of 8 elements, and for the first pass, um, what we're going to do is we're going to start at the index 0, and we're going to compare the next element. So is 5 or is 8 greater than 5? Yes. So we're going to swap those. And for the second pass, oh, I'm sorry, I'm thinking of selection sort. Yeah, so for bubble sort, you're going to move um, the largest element to the end of the list. And so for the next pass, we're going to, you see that 8 goes to the end of the list. And then we're going to find 6 as the next element, the largest element. And we're going to swap that with put that at the end of the list. And then once we hit the third pass, we see that 5 is the next largest element. So that gets placed in the next position. And then um, here, I might have explained that bad, but here for the first pass, this is the end goal of the first pass. So it's going to say for the array, starting array, we have 8 is greater than 5. So those are going to be swapped. And then 8 minus 4, or 8 is greater than 4, so that's swapped. And then 8 is greater than 2, and that's swapped. So it's going to keep going down the array until the largest element is at the end of the list. And then, so that's why 8 is at the end of the list. And for the next pass, it's going to go, it's going to find 6, and it's going to, or it's going to go 5 is greater than 4, 2 is greater than 6, 6 is greater than 0. So it's going to swap those. 6 is greater than 1, it's going to swap. And 6 is greater than 3, and it's going to swap. So that's why it's at the end of the list, the next position at the end of the list. And for the third pass, 5 is the next element that's the largest element. So we're gonna do the same thing. We're gonna compare each index and we're gonna swap them until 5 reaches its correct position. So is 5 greater than 4? Yes. Gonna swap the two. Is 5 greater than 2? Yes. It's gonna swap. And then 5 is basically just gonna move down the line until it's in its correct position. And then for the fourth pass, 4 is greater than 2, and then 4 is greater than 0, so it swaps. 4 is greater than 1, so it swaps, and then 4 is greater than 3, so it swaps. So the end position is right here for 4. And then for the fifth and final pass, we have, is 2 greater than 0? Yes. Is 2 greater than 1? Yes. Is 2 greater than 3? No. So 2 goes in this position. And at this point, the array is sorted. So we're done with that loop. So now we'll go to selection sort. So the idea here is that you are finding the minimum value in the array and you're swapping it with the current index. So we see here for this array, the first iteration is going to find the minimum value, which is 0, and our current index is 0. So it's going to swap whatever is at index 0 with the minimum value. So we see here that 0 or 8 got swapped with 0, as 0 was the minimum value found. And for the next iteration, the next minimum value is 1. So, and we're at position 2. So 5 is going to be swapped with 1. And then for the third pass, it's going to look for the minimum value here. And we're at the third position, index 2, if we're talking 0 index. So the next lowest value is 2. And so we're going to swap these values for the third pass. So 2 and 4 get swapped. And then for the third pass, we look for the next minimum value in the fourth position, which is 3. And 4 and 3 will be swapped. And then for the fifth pass, we're now in the fifth position. So the next minimum value is 4. So 6 and 4 are going to be swapped. And then for the sixth pass, we're going to be in the sixth position for index 5. And then we're going to look for the minimum value here, which is 5. So 8 and 5 are going to be swapped. And then finally for the sixth position, or the seventh position, or index 6, we're going to find the next minimum value, which is 6. And we're going to swap 8 and 6 to get the final answer of this sorted array. Does anyone have any questions about this process? Okay, we'll move on to the next question. So, as Abhi was talking about for today's arrays, now we'll go into an example. So, one approach that you can do is if you have a pretty busy for loop that does a bunch of operations, I would focus on one operation at a time for all the iterations. So we have this array A, and we have this grid that will fill out for all of the loops that occur. So as Abby said, the first axis is the rows, and the second axis is the columns. So, and the outer loop is I, and the inner loop is J. So for each outer loop iteration, uh, the inner loop is going to iterate through the whole entire for loop. So for I equals 0, it's going to go through j equals 0, j equals 1, j equals 2, and j equals 3. So if we're just focusing on the A array here, so for the first iteration of the inner for loop, I is going to be 0 and j is going to be 0. And so that's going to be set. This position is going to be set to I plus j. So if I is 0 and j is 0, the position at 0, 0 is going to be 0. So yeah, row 0, column 0, which is going to be the first position in the 2D array. And then if we ignore all of these other operations for now, and we go to the next iteration of the inner loop, j will equal 1. So when j equals 1, and since we're still in the inner loop, the outer loop is still going to be on the same iteration, so I is still going to be 0. So we're going to be still in the same row. And so for when I equals 0 and j equals 1, we're going to stay in the same row. We're going to move to the next column. And the value that you're going to set it to is I plus j. So 0 plus 1 is 1. And the idea here is to find the pattern that's occurring for each iteration. So you can see that we're staying in the same row for the whole inner loop iteration. And all we're doing is adding the current iteration of I, which is 0, to each iteration of j, which is basically just going to do or assign the first row to whatever j is for each iteration. So 0, 1, 2, 3. Does anyone have any questions for the first iteration? Okay, we'll move on to the next one. So now that this inner loop has finished, the outer loop is going to increment and move on to the next iteration when I equals 1. And when I equals 1, it's going to move on to the next row. And it's going to do the same thing as the previous row, but I is going to equal 1 now. So, but j is going to start at 0, and it's going to go to j equals 1, j equals 2, j equals 3. So you can see the pattern here is it's just adding I plus j at the current iteration. So I equals 1, so 1 plus 0 is 1. J equals 1, so 1 plus 1 is 2. And then 2 plus 1 is 3. And then 3 plus 1 is 4. And then now we'll move on to the last iteration, as when I equals 2, the condition in the outer for loop, 2 is the max value that you can get before this condition is false. So this is the final iteration. And similarly, we're going to just be adding the value of I to each iteration of j. So we have 2 plus 0 is 2, 2 plus 1 is 3, 2 plus 2 is 4, and 2 plus 3 is 5. And then that completes the whole for loop for just the 2D array for A. And then we'll move on to B in the next slide. So now we have B, and let me go back a slide. A was defined as 3 rows and 4 columns, and B is initialized to or declared as 4 rows and 3 columns. So that's why it kind of looks a little different. But so if we go through the iterations for B, start over, you can see that I and J got flipped. So J is going to represent the rows. So for each iteration, there's 4 iterations for the inner loop. So it's going to access the 4 rows it's going to access all four rows, and then I is going to be the columns. So if we see here, when j equals 0 and I equals 0, I'm going to set it equal to 12 minus count. And count is initialized outside the loop at 0. So for the first loop, 12 minus 0 is 12. And then for the next iteration, we're going to move on to the next row, which j equals 1. And this is going to be, count is going to get incremented, and it's going to be 12 minus 1. So the next value is going to be 11. And you can see the pattern here where count is subtracted by what count is incremented by. So at this point, count equals 3, so 12 minus 3 is 9 for the last iteration. And then for the next iteration, it's going to follow a similar pattern, but the changes to count stay for the next loop of I. So at this point, count equals 4. So 12 minus 4 is 8. And so that next value in the next column gets set to 8. And then it follows a similar pattern where count gets incremented with each loop. So the next value is decremented. We have 6 and 5. And then once we finish this, I gets incremented. And so we'll move on to the last iteration. And similar pattern, count keeps on getting incremented. So at this point, count equals 8. So 12 minus 8 is 4. And then that value gets updated here. And then I believe j equals 3. I believe I flipped these. I think I flipped these ones over because j is representing the rows. So let me fix that real quick so I don't give you guys the wrong answer, or if you need to refer to these slides later. Yeah, so j for b is representing the rows. So when j equals 0 and I equals 0, we got 12, and then it moves on to the next iterations. And then we have a question from Hunter. Does it matter if you switch I and j here on the side? Are you, Hunter, are you referring to these values on the side? Yeah, that was my bad. Yeah, this makes more sense for the j is representing the rows in this case. Yeah, I showed the subtle change of the switch between I and j, and I still made the mistake. So yeah, make sure you're paying attention to what's being flipped and what's being represented for the rows and columns. But the answers are still the same. And then for the, so now we'll look into the C array. And this is going over or utilizing the count as the index into the C array. So count starts off as 0. And all we're doing is taking the current iteration of I and multiplying it by j. So we'll see if we can find the pattern here. So first iteration is 0 times 0, which is 0. So 0 will be in the first spot. And then count is going to increment in the inner loop. So count will be 1 on the next iteration of the inner loop, and then that'll be set equal to 0 times 1, as I is still 0 as we're still in the inner loop, and j gets incremented. So 0 times 1 is 0, and then we increment count again, and then I is going to stay 0, so the first 4 iterations are going to be 0. And then once we finish the inner loop, I is going to get incremented to 1, and count is going to be still it's still going to hold the changes from the previous inner loop. So count will be 4 at this point. So it'll be in index 4, this spot. And it's going to do I times j, which I is 1 in the second iteration of the outer loop. And then it's going to multiply it by 0, and then 1, 2, 3. And then that's the end of the inner loop. And then for the last iteration of the inner loop, go ahead and show the answers here. So we're actually going to start at the end of the loop as what's it here? We have it here. So j equals 0, j equals 0, and the count equals 0. Okay, this one might be flipped as well. Let me see. Count. This would be a good debugging challenge here. So count equals 0. So for each iteration, count gets incremented. So yeah, this is reversed. So when j equals 0 and I equals 0, it starts at 0, and then we increment count, and it moves to the rest of the array. So this is actually reversed. You can think of this as the 0th position. So the answers that we were giving here are correct. It's just in the reverse order. And once we reach the second iteration of the inner loop, we have 0, 1, 2, 3 as I was incremented. And then when I reaches its final iteration, we have when I equals 2. So, and then it's going to go I equals 2 times 0, which is 0 here. And then 2 times 1, which is 2. And then 2 times 2 is 4. And then 2 times 3 is 6. Do you guys see the pattern? I'm sorry that it's reversed. I think it was thinking about the 12 minus count, but it's referring to the count that was being incremented itself as the index. Okay, we'll move on to the last array. And for this one, it might seem a little tricky from the index that's doing I times 4 plus j, but we'll see what that's doing. It's just a fancy way of indexing through the array one at a time. So when I equals 0, it's going to do 0 times 4 plus j. So if we're in the first inner loop, when I equals 0, j is going to equal 0. So it's going to access the first index. And it's going to set it equal to j plus count. And j starts off as 0 and count starts off as 0. So that's going to be 0. So the first index is 0. And then we move on to the next iteration of the inner loop, which is j equals 1. And So we're going to do I equals 0, so I times 4 plus 1, which indexes into the um, first index. And we're going to set that equal to 1 plus count, which is 1 or 2, as 1 plus count. Count got incremented in the last iteration, so the position in J1 equals 2. And then it's going to do that for the rest of the iterations for the inner loop. And then just to show the pattern for the index, if we increment the outer loop, so I equals 1 now, and then it's going to enter the inner loop, it's going to index into the next, I guess you can say, block. So when I equals 1, 1 times 4 is 4 plus j, and if it's the first iteration, it can be 0. So basically, it's just this I times 4 is the block that we're in for the inner loop. And then you can see here, if we started at the second iteration when I equals 1, it's just going to, and then the count keeps on getting incremented for each loop, the outer loop. So when count equals 4 and j equals 0, we're going to set that fifth index to 4, and then it's going to do that for the rest of the block. And then I gets incremented again, and it moves on to the next block. And I know this one's a little bit more messy, so if you have any questions about this one, then feel free to ask them in the chat. Okay. Yeah, we'll go back. So Hunter asks, is it the index that's uh, is it the index that I affects? So I is a part of the operation that affects the index. So for each iteration of the outer loop, so I is going to equal 0 for the first loop, outer loop, and then j is going to go through each of its iterations, so 0, 1, 2, 3, and then it's going to increment the outer loop again, so I equals 1, and then j is going to go through its 0, 1, 2, 3, and it's going to set each block of the inner loop. So the inner loop runs 4 times, so 1, 2, 3, 4, and then it moves on to the next outer loop iteration when I equals 1, and then it's going to go to the inner loop iteration, so 1, 2, 3, 4, and then it's going to do the same thing again. Since, is it the index that I affects, since it's not on the right side of the equal? Um, oh, okay, I think I know what you're talking about. So whenever you have accessing an array on the left side of the equal, you're indexing into the array. If this expression d I times 4 plus j, and then the brackets around it to access the array was on the right side of the equal sign, then you would be accessing the elements at that index, and it would return an integer. But since it's on the left side of the equal sign, you're only assigning the value at that index. So the left side is the assigning of a value, and the right side is what you're assigning that value to. And then We have another question. Can you explain I equals 1? Because I kind of got confused, especially with the I times 4. Yeah, so once we reach I equals 1, so that's the second iteration of the outer loop, we start the inner loop over again, but count stays the same, or not stays the same, but what's the right word? The changes from the previous iterations um, still hold for the other loop or the next loop, as each time the inner loop runs, count gets incremented, and for this section, count got incremented 4 times. So since count was not reinitialized for the inner loop, it's going to stay the same for it's going to equal 4. So for when I equals 0 or I equals 1, we're going to do 1 times 4 plus j, and this is the start of the inner loop, so j equals 0. So that'll be index 4. So 0, 1, 2, 3, 4. That'll be the start of this this iteration, and then we're setting that equal to 0 plus count. Count at this um, at this at this point is 4, so we do 0 plus 4 is 4, and that's why the index at 4 is also 4. And then we move on to the next iteration of the inner loop when j equals 1. So we have I equals 1, so 1 times 4 plus 1 is 5. So 0, 1, 2, 3, 4, 5. And then we're setting that equal to 1 plus count. And since count got incremented in the last iteration, it's going to equal 5 now. So 1 plus 5 is 6. Does that pattern make sense? Okay. Then any more questions for this example? Okay. So now we'll move on to some of the array functions that were on your handouts. So the purpose of this function is to see if an array has a certain item, and if the array contains that item, we return a Boolean. So since we're returning a Boolean, what do we want to put as the return value here? What is like the keyword? Yeah. So this item has item function is going to return a Boolean. So now we're gonna, so what we want to do now is for arrays, if you want to access each index of the array, you want to loop over, you want to use a for loop. You could use a while loop, but for loop is might be a little bit easier. So we want to, what might be the conditions that we want to put in our for loop? We want to initialize I, so int I equals 0, and then how many iterations do we want to loop for? What is the condition that we want? Yeah, Alex is correct. So yeah, if you can use any variable name you want, but I is the one I chose in this case. So initialize I to 0, and we're going to go as long as I is less than n. And Hunter says, would it be x is less than or equal to n? So if n is the size of the array, we can go back to this array. So if n is the size of the array, so this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The size of the array is 12, but the max index that you can access is 11, since it's 0 indexed. So let's see, the first position is index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So yeah, if you do less than or equal to n, then you'll run into like a out of bounds error because you're accessing an element that doesn't exist. Yeah. So if we put the left in, then I will only go up to 11. And then what do we want to check in the if statement for whether the array has an item? Yeah, so Alex has the general idea of array. If has item equals item. So what we're checking here is like the actual elements of the array. So how do we access the elements in an array? It's kind of similar to the I think I just showed it, but um, yeah, Alex, that's right. So we want to access the array at the index in the for loop, and we want to check to see if the index at that in the array is equal to the item that we're checking. So we're checking if a at index I is equal to item, and this is just a small thing, but for what you had, yeah, it's the parameter itself is declared as an integer, so you'll just be comparing the two since the array A is an array of integers, so you can just compare them. If you had the single tick quotes, then you would be comparing a. I don't think it would compile because I think the single ticks represent a char. So yeah, you have to compare types that are equal to each other, but they have the same type. So if you index into an array of integers, it'll return an integer, and then you're comparing it with another integer, which is item. And then, yeah, if this is true, then we found the item, so we want to return true. And we don't need an else statement here because if it returns true, then we have um, returned from the function, nothing below it gets executed. But if this if statement doesn't get executed, it's going to go to the um, next instructions after the or next lines of code after the if statement. So the last line is return false. And then Hunter asks, is it possible to access a slideshow after the meeting? Yes, well, I'll see if I can get the professor to post it on Canvas. Um, I'll just also post it in the Discord. You don't have to worry about joining the Discord. I don't think I have an invite code to invite people, but I'll just post it there just in case some of you are in the Discord. But I'll try to get the professor to post it on Canvas as well. And then this one, I didn't animate, so it's just showing the answers, but I'll walk through it. So this is a function that has same position. So we're checking to see if we're checking two arrays, and we're checking each element in those two arrays at the same index. And if the elements at that index are equal for both arrays, then we return true. So similar to the last one, we want to return a Boolean. And since we're looping through an array, we're going to have the same conditions of starting at 0 and going until the last element of the array. And our condition here is since we're checking the same index in both arrays for each iteration, we want to access each array at the same index. So we're going to use I. So I is going to be 0 for both of these indexes for the first iteration. And then it's going to go all the way to the end of the array. So if it ever finds a value that is equal for both arrays, it's going to return true, otherwise return false. And then that's all the examples I had for this review, but we can go into Q&A and you guys can hit us with any additional questions that you have, or if there's any topic that's not clear, we can go over it. But what's it called? Yeah, sorry that there was one question that was a little bit off. We can redo this if you guys really want to, but or if you need to. But yeah, other than that, does anyone else have any other questions? So we have a question from Hunter. When do you use void for a function instead of naming it like int or double or bool instead? So for an integer, or I'm sorry, I saw something. Okay. So for a void function, the idea is that you're not returning anything, but you are able to do operations inside that function. So whenever you don't want to return a value, but you want to be able to, let's say, edit a variable or something that has a lot of operations and you want to put it in a function, I think that would be the best case for using a void function. So I'm not sure if you all have learned about like pass by reference versus pass by value. Does that sound familiar for you all? Yeah, I think we did go over that for the midterm review. So if you have like an object or a variable that you want to um, run operations on, and that there's too many operations to just like put it in main and the code looks ugly and you want to put it in a separate function, you can do that. And then when you want to call that function to edit a value, um, you'll be passing it by reference, so you'll be editing the value directly, so you won't need to return it. So that's the point of the void function, when you don't need to return anything because you're editing everything inside the function itself. Does that make sense a little bit? Or I can go over an example as well if needed. Yes, Hunter, that's correct. And then did the professor mention if we do binary search exercises? He didn't mention that, but I believe in one of the handouts it said that it went over bubble sort and selection sort, and then it said you'll be learning more sorting algorithms in the future. Um, but yeah, he didn't mention binary search exercises exactly. And then another question, should we mainly focus on handouts and test banks, or do we have to study the homeworks too? Uh, yeah, this is another one that I would take up with the professors or TAs. Um, but I would assume that the homeworks would have topics that it would be better to be comfortable with for the exam. Um, but yeah, I don't want to say anything that's not true, but yeah, I would confirm with any of the staff for the class as well. But other than that, you guys are free to go whenever, but we'll stick around till for the next 5 minutes if you guys have any more questions. And thank you guys for attending. Yeah, you can see the swap and remove. Jerry, can you quickly go over the first couple slides? Yeah, we can go over the first couple. Abby, do you want to go over the first couple slides again? Just a quick summary. I think Abby just returned. Abby, do you want to go over the first couple slides, like just a quick summary of each topic? I think one of the students wasn't here for the first part.
Okay.
Should be
Which
like
slides? Like all the slides or what?
just the first four, like the
Because I mean, like the meeting is recorded and we'll be sharing this recording to the professor so you can view the entire session, like whatever you want.
okay, yeah.
Yeah, so I think that's better.
Yeah. Yeah, just to go over like what we've been over, just arrays, insert, swap, and remove for those arrays, and then two-dimensional arrays, and then vectors.
Yeah, I was just going over a few examples from the handouts related to these topics. And yeah. Yeah, we'll be sharing the slides as well as the recording as soon as the session ends. We'll send it to the professor. Yeah.
Yeah, we did the professor. I think the professor did he tell you that the exams start on Monday? Because I'm pretty sure. Yeah, from what the
Yeah, he told me that it was gonna be on Mondays, so he wanted the review session to be like either today or tomorrow. That's what.
Um, yeah, because when I asked the professor like 2 weeks ago about the exam dates, he sent me like a website for the exam dates, and my class is like at 11 a.m. and it should be on Wednesday. Like I'm kind of surprised that it's on Monday. Maybe it's like for another class. Like, how can I confirm this? Because I emailed the professor, and I don't think I'll get a reply today. Yeah.
Does everyone here have the same class with him, like the same day, same time? Because if you guys have like different timings for the class, then you could have different dates.
Yeah. Oh, sorry. Well, there's like two main classes. There's 11 to 12:15 or 11:15 to 12:05, sorry. And then after that it's like 12:05 to I think probably 1:10 or something like that. I'm not sure exactly when that one ends, but I'm in the first one from 11:15 to 12:05.
Yeah.
Yeah, so
Did the
yeah,
professor say anything or no? Last classes.
I mean, to us, he just told us that the exams start from Monday. So I mean, if there's different timings, then
Ah,
probably you could have different dates. Just check the final exam schedule and check your timing, and that's probably the one you should refer to.
Yeah, yeah, okay. Then because like I got a heart attack. والله.
Yeah, I checked the schedule too, like when that was mentioned, like an
Yeah.
hour ago, and it does look like it's going to be on Monday. So maybe perhaps he made a mistake because I feel like I remember in class he like said oh it's going to be at 11 or sorry on Wednesday. So yeah, that kind of was a little scary. Sorry, I don't mean to get too administrative and stuff, but
Yeah,
Yeah,
that's okay.
it's good to know that now. Anyways, good luck to everyone here.
Good luck,
Come back.
guys. Yeah, yeah. I'm looking at the schedule.
So your
Uh,
class is on Monday, Wednesday, Friday, right?
Yeah.
yes.
Monday, Wednesday, Friday, 12, 10. Yeah, so for the people whose class starts at 12:10, it's on Monday,